Think of software vulnerability like a car recall notice. You manage a fleet of 100 cars, but the workshop can take only 5 this week. Some recalls are minor, say noise whippers. Others are critical, like a faulty airbag that could cause a real harm. Which 5 cars do you send first? That's our reality in cybersecurity. Many no vulnerabilities and very limited maintenance windows. We need a consistent way to choose the fixes that prevent the biggest accidents. Hi, I'm Danilo Franco, Product Manager in Cybersecurity. Many things still really on generic heuristics like raw, CVSS, that often pushes effort to large issues, not likely to be exploited ones. Which exposed servers, a single bad call is costly. We need precision, not noise. Machine learning turns heterogeneous signals, vulnerability scanners data, EPSS, CVE, asset context into a single risk score. Result, fewer incidents, lower MTTP, and we can prove it with recall, AUC-PR, and calibration. Our business goals. It's reduce exploitation in production, shorten MTTP for high-risk CVS, add predictability and governance to pet planning. The key factors are EPSS, KV, public exploit, CVSS vector, if asset its exposure to internet, our open ports, and asset role. How it's work? We consolidate scanners, vulnerability scanners, CMDB, EPSS, CTI, and logs. A calibrated gradient boosting, like GBM, model produces a risk score with SHAP explanations. Output is a daily queue plus recommended actions. How like patch now, isolated, WAF, or schedule. How can I validate this solution? First, back test with time split against CVSS, EPSS baselines. This is the architecture. Now it's a demo, but in real world, we run into the cloud to unify data and governance. Offline periodic training, weekly or daily incremental, with drift monitoring, batch scoring daily for the full queue, plus event-driven rescoring in minutes for new CAV or EPSS, and IOC spikes too. This is a list of risks and controls about this solution. And now we go to practice. This is the technologies. So we use this stack, Python 3 with light GBM, scikit-learn, pandas and NumPy, and SHAP to fast and explicable. To the interface, we use Fast API and the Streamlight to dashboards. And my storage, I use Parquet and the SQLite and CSV. And the charts, I use Plot and Matplotlib2. And quality, PyTest, Roof, Black, and MyPy. This is the message. Smart action, not late reaction. My name is Danilo Franco, and thanks for your time.